Thank you. Okay, thank you very much all for coming. We're going to start with a slight introduction into what gRPC actually is. And just to get familiar with you, can you guys, I know this is a bit awkward, but can you guys raise your hand if you're completely new to gRPC and like have no knowledge of it? Okay, thank you very much for participation. And some beginners and getting to starting with gRPC? Nice. And experts or advanced? Thank you. At least we know. Okay, so I hope I can maybe tell you even something new, even for the advanced and intermediate ones in this very short 5 to 10 minutes introduction thing. So it's like I'm 5, but I assume that you have at least some knowledge of at least GraphQL and RESTful APIs and so on. Okay, so what is gRPC? gRPC is an API technology, the same way you have like RESTful API, GraphQL APIs, SOAP APIs, for example. It's a different kind of API, it's a gRPC API. It went open source at 2015, and it's an open source version of Google's internal RPC framework called Snappy, so it has some history even before that. And it is schema-centric like kind of protocol, the same way, for example, you have schema for GraphQL, you have a schema for gRPC. So it's like strong contract kind of API communication. It doesn't have a GraphQL schema. It has protocol buffers. You might know protocol buffers, for example, it's used for describing messages, for example, even in some MQ systems. But it has an extension where you can define like services and RPCs to call. And yeah, what is RPC even like? What does it even mean? The idea is that you want to like remove or minimize friction between doing like a network call, and you want to make it as easy as possible, possibly as easy as calling like a function or a method on your class or object that you have locally. So if you look at the image, you can see there's some C++ service, there's some Ruby client, Android Java client, and all of them have this darker part, which is like the gRPC stuff. And this gRPC stuff is usually some code that's generated from the schema. And from the client perspective, you have some like service class generated that you can instantiate with some like connection arguments, and then you can call methods on it and get arguments from it. On the server, on the other hand, it generates you interface, and so you know what to implement for the functionality. So this is what RPC is like. And I don't know if there are any Java developers, but this is not a novel concept. There was a lot of RPC technologies and frameworks before that, and probably the most similar one, at least as I'm aware of, is Java enterprise thing called remote method invocation. The idea is just the same. Okay, as I said, you probably, as you've seen, like the stuff is generated on the clients, on the platforms. So you need to have support for that. And there's like some like generous sum of supported languages and platforms. So these are officially supported. If you're doing something else, you might be stuck with some like community implementation or like no implementation at all if you're out of luck. Okay, maybe what is unique about gRPC? What distinguishes it from the other technologies that you might know? It's rich like call type model. One thing to know that it requires you to use HTTP2, which is kind of a bummer if you maybe need to deal with some like clients, but okay, it just requires HTTP2 streaming. And there are 4 actually types of communication. The first one is the most basic one. It's the unary, and it is the communication model that everybody knows. It's like the request response kind of communication. So client initiates the connection, sends the message to the server, it processes it, and then it returns a single message. This is what you know from REST probably, from GraphQL like queries and mutations. This is the type of thing. And then you can just generalize the concepts with streams like all the way. So the first that you're still probably familiar with is the server streaming. And the model goes like this. The client initiates the connection and sends like a single message. And then a stream is opened between the client and the server can send a stream of messages. It can be like all messages at once. It can wait for a second and then send another message. Each of the participants in the communication can end the stream and say, hey, I'm done. And now there are these two that you maybe have not seen, or they're a bit unusual. One is client streaming, and basically, oh, by the way, sorry, the server streaming, these are GraphQL subscriptions, by the way, and like the model of the communication. And the common use case is like watching changes over some resource, right? You open up, hey, I want to watch this thing, and the server sends you like the diffs as they come. The client streaming, on the other hand, is the generalization in the opposite direction. So the client sends messages, and when they're done, server returns a single message. The use case for it is like a bit vague or hard to wrap your head around, but for example, client heartbeats, when I want to say, hey, I'm still editing this thing, or I don't know, stream some events, for example, as my eye tracking device or mouse moves. I want to stream all these events to the server. So this could be an example of a client streaming RPC. And finally, you can go full bananas with like bidirectional streaming, which is you open up a channel and you can throw in messages, receive messages, and it really depends on the implementation, on the agreement between the client and the server. There's no amount of defined like, should I send one message and wait? It's like up to you. You can pretty much do what you want. Okay. So these are the 4 types, and I will just show you like a few examples of each of the communications so we can actually look at the schema. So as I said, it is defined in a schema, and this language used is protocol buffers. It looks like it consists of definition of messages, and finally the service, like the functionality. So the first message is like a cat that has a single attribute called name that is of type string. The other message, get cat request, looks exactly the same. And finally, you have a service. It has a keyword RPC in it. It means it's the functionality, the function that you can call. So in this case, we have a cat service that has one method that you can call. That's called getCat, and accepts the getCat request, returns cat. Fairly simple and obvious from the description. For the other type of communication is the server streaming. Now we have example that I want to watch cats, so I initiate the communication. I send in empty message, that's completely fine. And notice the stream keyword in the response. This actually indicates that this is a streamed response, and so I open up the connection to watch cats, and some cats might come out of the communication. When I'm bored of watching cats, I can just kill the thing, or when the server ran out of cats, you can just end the stream as well. Third type, as I mentioned, is the example of a client stream. As I mentioned, this is like usually some kind of heartbeat kind of thing when client sends messages and eventually waits for the response. So here's a use case where, let's say I'm a cat and I go for a midnight stroll and I want to send every second my location, like latitude and longitude, to the server. And finally, when I'm done, I'll end the stream and the server will return a single message with some statistics regarding my trip. And I'm happy to see like how far I traveled. It's like Strava for cats. Notice the stream is now in the input in the share location request. And as you might have guessed, how do you define bidirectional stream? Just include the stream keyword into each, like request and response part. And yeah, there's a bit odd example where you can feed cats. So you open up the channel or the stream, and you can send in food. And some cats might come out of the stream to be happy to eat your food, but it might not happen. And even some cat might come even when you don't throw in some food. So this depends on the implementation. And this was a very quick introduction into what gRPC is. And I'll have another bit longer talk right after this. But now if you have any questions, you can shoot them right now. Any questions? Yes, thank you. Very good question. I am not going to talk about transport layers in the future, but I should have mentioned something at the very beginning, and this is this communication. Thank you for pointing that out. Good thing to know that the transport layer is defined by the protocol buff technology, which is a formatted, as I said, it is used as describing messages, and protocol buffers actually define how the messages are serialized down the wire, and it's also important how it happens, but it's interesting to know that it is binary encoded, so it's very hard to see, like, by just looking at what's going on. It doesn't use JSON or any kind of thing, so basically the only thing that you can see in the message when you like open it up and look at it as a human are the strings. But basically, our enums and numbers are very hard to read. There's one more thing to know. It's not just protocol buffers. gRPC adds some specifications to the communication, and it is basically sending some status code and some metadata that's encoded along with it. So, great question. I think the only takeaway is that it's binary encoded, like the messages, and I think anything else is way too specific, and I don't even know like any other answers to more detailed questions if you might have. But thank you very much for the question. Anything else? Cool. So initially I wanted to do like a beer break, but I guess it was so short that nobody needs to refill their beer. Is there anyone who wants to refill their beer? No, it's pretty easy. So I'll just take a sip and we'll move on with the next thing and we can get to the real stuff. Okay. So what I wanted to share, by the way, my name is Jaroslav Šmolík. I'm backend tech lead here at Ackee, and I wanted to share you like something that we did that I think is cool with our Node.js gRPC framework called protocat. So let's get to it. What's it going to be about? I'll briefly explain what protocat is, say something briefly about history and what we do with gRPC at Ackee, and then go through several cool stuff. Less cool middlewares, way cool caching, but we need middleware to speak about caching, and finally mention like some of the things that are other things that we did. So let's get to it. Oh, what is protocat? Protocat is, as I've foretold, is a gRPC framework for Node.js. It has this very cute domain that's totally legit and it's not a scam. And I wanted to tell you a bit about what the project is, and I thought, hey, let's use the method that people liked 10 years ago, and these are the badges. So you can see that I'm not the only contributor, so it's a legit project. There's 3 of us. It has 46 stars and counting as we speak, hopefully. It has some PRs. You can see we didn't write it yesterday, right? It has some history, but it's not something super impressive. It has some downloads, and yeah, it's written in TypeScript, several releases. It has a few lines of code, so you could, like, I almost had it in the slides, but I had to delete it because it was still so boring, but it's not something, some large code base. So, yep, this is what it is. Also, the coverage looks like a scam along with the URL, but it's actually just rounded up, so it's 99 point something, so it's total legit thing. So, yeah, that hopefully covers the title, what is protocat? Everybody wondering what the hell is protocat. So, hopefully I have answered that. And now let's look into a small history entrée that we have on what we do with Ackee, with gRPC at Ackee. So basically we use it for server-client communication, which is a bit odd. Usually people, when we say gRPC, they say, oh, you mean backend to backend? And we're like, no, we use server-client communication. And we pretty much like have hands-on experience with every language there is, because we have like all of those clients. I over-exaggerated a bit, but we have like a JavaScript web client. Android, I think I might be kidding, but we definitely have implemented in Kotlin, and I think we've tried even the Java SDK before, and yeah, some SDK in Swift. By the way, I think Swift is not officially supported language, so I think we might have used like the community thing, or a lot of things have bridges to the C implementation. I just realized that now, so you can even do it with not supported language. We have experience over 2 projects, which seems very insignificant, but these were very large projects, and both of them have like not 3 years, but 2.5-ish, almost 3 years of development, and almost all of the time is in production, so I think that's kind of cool. And finally, I pulled the stats like one week ago or something, and we had like about 3K daily users, and several times a week there was a peak of 25 RPS. These were both news applications, so it has like unstable traffic. Usually nobody uses it during the night. There's some people using it in the morning, and there's like high traffic peaks as something happens or a notification comes. So yeah, you could argue like, hey, it's not so much relevant. I would argue that maybe it is, because it's not it's not Google, right? But it's enough RPS, it's enough traffic that you can actually test things in the production and see if your concept is completely broken or not. And actually managing something or maintaining something for 2+ years is actually gives you. It's not like we're weak in production. We had to go through like a lot of things and compatibility changes that we did throughout development. So I think it makes us kind of relevant to speak here. So let's look at the timeline a bit. In 2019, we kind of started thinking, hey, there's a gRPC, we might have used it. At May, we started like an active development phase when we searched into like the protocol specifics, the web support. I don't know, what are some frameworks that we could use, and so on. And then not so much later, I think 1 or 2 months, we had like a first commit in the gRPC API repository. And at this point, by the way, I'm not sure I mentioned this, but everything is in Node and TypeScript. I might have, but none of our backends is in something else. So we used Molly.js, which is still, I think, the most popular thing there is to be used for Node and gRPC. This is the authentic commit message. I really like how it's worded, like basic gRPC implementation by our colleague Michal, who helped us like create this event. So kudos to him. We're not like super mad about Molly.js. It helped us a lot, but there were some things that we thought we could do maybe better. And namely, this was like some developer experience and type safety with TypeScript. And secondly, we wanted to do some cool optimization tricks that we couldn't do with Molly.js. So about 1 year later, I started prototyping this prototype of protocat and experimenting with it and see if we could use it to replace Molly, and then eventually develop some features so we could really use the power of gRPC and introduce some more cool things. And of course, as it goes, like 1 month later, it was released, and in production 2 weeks after that, and there were nothing broke. I think it was very, very smooth replacement. But at this point, it was 1-to-1, like the features from Molly that we needed, so we could do the migrations. And from this point, we thought, hey, we can now work on the magic. Okay. Valid question is, why would you even need something like Molly.js or protocat when gRPC is already a framework? And it's a good question. I'll try to answer that in this first section. So this is gRPC.js. It is the official framework that you would use for Node. And it's a very short snippet. This is actually, I think, the hello world. I just replaced the hello with cats. But apart from that, it's probably the same. So if you look at the main function, you can see that we just create a server, same way you would create like HTTP server or Express server or whatever. And you add a service. And this is, by the way, the cat protocat service is something that you have generated from the schema, as I showed like in the first section. And you have the implementation of getCat. And the getCat is the function that you have at top. It's very simple implementation, just returns the cat prefixed with cat. It's very, not that much, right? But this is basically all the API that you get with gRPC.js. It's not literally speaking, but regarding the functionality, this is like almost complete example. And so one thing that you need is, for example, add logging. And now at this point, you have no other option but to prefix all your handlers with some function that does the logging, which is kind of awkward. And this is why actually Molly.js, I think this is one of the best selling points of the framework. And this is actually why we used it, why we needed the framework at the first place. So looking at the example of protocat, you can see the bottom part is exactly the same. It's just get cat, return response, set name, cat, like plus whatever the client sent. But notice this nice upper part, and we can now add something like a middleware that has logging that gets applied to all the RPCs that are invoked. This is not so impressive, by the way. This is what Molly did as well. It's just a build-up to something much more grandiose. So why aren't middlewares in the official framework? And it's a good question. I will try to show it on this example. Let's go through it like shortly. It's a short snippet. So we see the middleware as we seen in the previous slide, and it logs something on the output before everything after it happens. It's the next call. It is a similar thing you might know from Koa, if you know Koa. And finally, when everything is done, like the handlers and stuff, we log like the end bracket. And now we have a service that just logs cat emoji. What is the expected output of this? Shout it out, it's easy. Cat in brackets, exactly. Thank you. It is cat in brackets. This was easy. I was testing you. So let's go to a more complex example. Let's say that we don't have a unary code, but you have a stream. The middleware is exactly the same, but now we have watch cats. So it's written several messages. You can see that this implementation of run twice after some time is not here, but you can imagine that it just continues on going and waits a second, then sends a cat, locks cat, waits another second, sends a cat, locks cat. What would you expect to be the output now? Anyone? This obviously depends on the implementation. I'm just asking, like, what's your design decision would be? Any suggestions? Multiple cats in the brackets, thank you. That's one option. Any other opinion? Just brackets and cat after, thank you. Anything else? Okay, so let's go through possible options. Actually, I was foolish enough not to include cats in brackets, but it's a good good thing that you said it. Basically, I came up with these options. At least one of them was heard here tonight, that it's like brackets and then like all the cats. But basically, there are several ways you could do it. For example, the first one is obviously that the closing middleware should happen when the stream ends, and you should do open middleware cats, close middleware. The B is as you said, that is open, close, and all the cats. And I came up with a solution that, for example, the close code could be called of the middleware for each of the response messages. So it means it doesn't pair up, but it one open code, and for each response message you get like the closing middleware. And actually, you could make a pretty good argument for each of those decisions. And so I guess it's so opinionated. It's not in the main framework, and it's up to you to decide. But we thought, hey, let's make a decision and move on. So what we did is, by default, protocat behaves the way the B does. So it, as soon as the resolver or the implementation ends, the closing middleware is the closing code of the middleware is executed. And yeah, the cats can come after it, but it's all promises, and you can actually make it to behave like A when you resolve the promise only when the stream ends. So we thought, hey, this gives some flexibility to the developer. And also, you could, if you tried, you could make it work like C, because you can actually call the next thing multiple times, but it would be a bit weird. You cannot do cats in brackets, though. It's a good point. We forgot to do that. So basically, this is how the middlewares look in the protocat. Let's say this is more complex one, but it just has some like try catch thingy. So it just has error catching in that. But basically, we made the decision, hey, this is called immediately when the next resolver is done, next handler is done. And if you want it custom for streams, you can do it by delaying the promise. The same is for catching. And eventually you can even do some cool stuff with propagating errors on streams, but this is a bit hacky, so we don't do it by default, and we provide a special middleware for you to do it. But it's actually pretty cool stuff. We thought, okay, yeah, how do we implement this? And actually, this is the part when I had the implementation slides, but it turned out to be extremely boring. So let's just go through the boring part and show you only the exciting code, so we don't waste our time. So basically, the boring code is that for like each of the middlewares and handlers, for each RPC, we condense all the middlewares and the handlers into a single function that we just register to adapt for the gRPC JS. This is the name of the library, by the way, the official framework. So we just do adapter to the API, and we add some adjustments like, I don't know, add some context and propagate properly error handling and handle the metadata sending and blah, 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 blah. And the fun part is, and I think this is like the most exciting thing I've ever wrote, even though it's like a bit heavily inspired by the Koa implementation, but this is like the waterfall implementation of the condensing like middlewares and handlers into a single thing, and I think it is just beautiful. I'll just quickly go through it because I always get lost in it, but basically it's a composed middleware, so it gets all the middlewares and returns a single middleware, as you can see on the first line. On the second line we define like an anonymous function that has the signature of the middleware. It receives the call, which is same for all the middlewares, and the next, which is the chain of calls like through the middlewares to the handlers. And yeah, we define a dispatch here, and the dispatch is a recursive function. And I wrote here a note so I don't fuck it up here tonight. So dispatch n+1 is the next function for the dispatch n, and you can actually see it in the recursive call on the line. I should have added line numbers. Anyway, in the await middleware I, the dispatch function basically just takes the middleware at index I and supplies anonymous function with dispatch I+1. This is not gRPC related, but it's super exciting. Anyway, this would be all about middlewares. We'll come back to this very briefly, so I hope your time is not lost and you had a great time. But what I want to say with this is, with this compose middleware function, it allowed us to do one cool thing. And is anyone familiar with OpenTelemetry or some kind of spend tracing? Okay, great, thank you very much. So we use Trace Agent, which is like Google's thing, but it's basically like OpenTelemetry thing, where the thing is that you have like a production code that's slow and you want to see, hey, what is slow? So it allows you to do like spans in the code, so you can see what took how long. And this is an example of some call, and basically the compose middleware thing allows us to implement like this spend tracing thing automatically for all the middlewares that we register. So for example, you can see on the first line the RPC is called, then we have some CLS middleware, then we have some logger middleware, then we have some Redis get that would be very hard to place, but thanks to the spend tracing we know that this is from authentication middleware, so this is basically some cache hit into Redis to get the user. So this is one debug superpower that we got thanks to using the protocat, which we knew how to plug in these things. Okay, and the last part is the most exciting one, and it is application cache. Martin will speak about on why this is done in the application, because it's very hard to do on the network, and there's like so many reasons with gRPC. But basically imagine that like there are no network proxies that could do like caching for your RPC. Like, so we thought, okay, we need to do something in the app. This is not so far from the truth, by the way. So we wanted to do application cache, but we wanted to do in Node, and we wanted to do it fast. I almost giggled at this because I think it's hilarious, but it was not a well-timed joke, so sorry for that. I'll go a little bit through like the history on what went on. So the basic implementation that we had, a very simple sequence diagram. You have post on getCats. Basically, this is what happens on the gRPC server when somebody calls like a unit RPC. So a post comes from some network. It is someone calling the gRPC. Everything's done through post, by the way, and as we know, thanks to great question, that everything is binary. So basically we have this message incoming in that's binary. The gRPC server catches it, processes it, and creates the nice messages for you and passes them down to get service. You get the message with all the nice code generated thing that you have, and in a very naive implementation you would fetch something from a blue, which is like Postgres, MySQL, whatever database, and you would return it, and the gRPC server or /molly/protocat would return the thing. This is very naive, and it doesn't handle 25 requests per second if you're not doing something super trivial. What we did is we thought, hey, we need to improve this, so let's add Redis, let's add some kind of caching of the database calls. So basically the schema is just the same, but before we go to the database, we get things from the Redis, and yeah, if we miss it, we just do the same thing as we did previously, but if we hit it, we just go back and we just save the call from the database. This is super cool. We designed it, discussed it, said, hey, it's perfect. So, okay, let's do this, and went pretty much like this. Tonda, who is here with us tonight, said, "Hey, let's just deploy it before the stand-up." It seemed like a hilarious idea, and it didn't perform as we expected. This is a sarcastic zap, even it's not obvious right now. But basically, we had very slight improvement in something that we expected to improve greatly, and Tonda, who is here with us tonight, actually managed to identify the problem like very precisely and very eloquently described it as the problem of JSON parse a whole lot of shit a ton, and it is very it is just as elegant as precise, and it was basically the issue. So let's look back at the example. This is what I showed you, but with some blank spaces, and what actually happens is there's a lot of, sorry for that, a lot of serialization happening. Basically, we save the thing in Redis in JSON because we're in JavaScript. We fetch it from the cache. Now we need to parse it to get the JavaScript object. Now we need to fill these JavaScript objects into the classes, which are the classes generated by the client, by the gRPC kind of thing. So it then can be serialized into the binary. So you could say, hey, it's like, what's going on? You're writing a Node, you could probably handle this. It's not going to be super performant, but this is like the weak spot of Node. You actually just kill so much CPU because these are all synchronous operations, and you kill just so much CPU on just, and this is cache hit, right? These arrows are what happens when you hit the cache. So this should be the happy path that does like almost nothing, but yet on 25 times like per second, it does like all of these crazy things. So we thought we don't even want to like do this. It's not, we don't want to use any intermediate state. It's just like shoveling data back and forth and doesn't even help us. So we thought, hey, let's get rid of this. And we couldn't do this with Mali. So cheers. So yeah, even it doesn't look like that. This is one of the slowest things that like bugged us really much. So let's rewind back and go back to middlewares. This is gRPC.js again. You can recall this example. This was how you add a service to, how you add an implementation to the server. This is what we saw in the first example, how to use gRPC.js without protocat. And there's an alternative way that we use it in protocat. And it's just more verbose way where you can just define individual RPCs. But what's super cool in this is that you can add some more data. And the more data is the functions, how to serialize response and how to deserialize request. So we thought, hey, we could actually like maybe use this. So this is the implementation of protocat, which is the boring code I didn't show you. But there's one exciting thing. You can notice the bottom part is just what I showed you on the previous slide. It's just registering of an RPC, right? This server register, some kind of code gen, handler, and there's not like the response serialized right away, but there's this if. And question on everybody's mind is like, is it safe? Like passing some random binary data, and like it's a good question, and I can explain that maybe better after the show, but let's not dig into it. It was the best decision we made, I think. And basically we just wrap this around and provide the middleware for you. So basically all you need to do is give us some hashing function that takes in the metadata, the request, and so on, and creates a string. And you need to give us like API to a storage, which is probably going to be Redis or some kind of similar kind of thing. And we give you the middleware and handle like all the things. And how does it look like? By the way, the invalidation, again, good question. If you're interested in it, I can explain it deeply, but basically you need to do it manually. It's the short answer. How the communication looks like after that is basically protocat handles get request. It calls your generate hash function to create a string. Now, using that string, gets thing from Redis, where the binary data is stored right away. So we skip all the serialization and we can return it right away on the cache hit. If the cache misses, we need to do like the same thing as we did before, but notice that we don't need to pollute any cat service or any code deeper with the caching, and we can handle it like very nicely here. So we actually got rid of JSON parse, create cat service, set all the things, and then serialize it on the response. And the caching previously was okay, but it was very bad for calls that were returned a lot of data, and were very cheap on the SQL. Now we kind of smoothen up the things, so even when you have kind of cheap calls to the database, but the data is extremely large, we save like a lot of things thanks to not doing the back and forth serialization. So yeah, this is how we solve the caching problem. And what are some other things that we added? And I don't have time to speak about in more detail. Basically, when we started like 2-3 years-ish ago, there was a big fuss about what library to use for Node. There was the gRPC, which was like the port to the C bindings native thing, and then there was now native is very confusing, but the thing were written in JavaScript, and everybody said, hey, don't use the gRPC, use gRPC/gRPC.js. So we were actually the first one, I think, who used this library, and there were like a lot of issues you can't imagine. That they said, hey, let's just use the new thing at this cost because you're using like this old deprecated kind of thing that we're not going to develop. So we made this transition, which was really cool, but it's not so magnificent right now. We are the first one to do like a full stream support. Basically, when you open the documentation of Mali.js back then, it was like, hey, this worked for Unary, but if you want to do like streaming, like good luck, do it somewhere else. But it really improved, and Mali.js is like a decent competitor to protocat right now. And what we did as well, which was one of the problems that I mentioned at the beginning, is type safety. And there's a star because I think it's still fair enough, like competitive kind of implementation. Yeah, we added some management of metadata, and finally some error handling, which is again, I think exceptional, mainly due to handling of errors in the streams. And finally, what we added like a few months back, actually we didn't add it to protocat, we made like a generic implementation that you can plug into any server using gRPC.js, and we implemented the long-missed gRPC reflection for Node, which is like an introspection of the schema, so the client can sniff around and see what's the schema. It's like introspection for GraphQL. So yeah, finally, I would like to show you this. This is, maybe some of you recognize this. This is NPM trends. This is basically how much people download your packages. So when we started protocat, at least when I started the prototyping, I thought, hey, this is going to change the world, man. This is going to be like the new Express. And obviously it's not the new Express, because the blue line, of course, is Mali, still to this day. And it wasn't even close, because the orange one is, of course, nice gRPC, which started like suspiciously enough about like 3 months after we released protocat, which doesn't seem too nice to me. But yeah, so we did leave like almost no impact, but I think we still did like a lot of cool things and learned a lot about gRPC, and thus it's our pleasure to share some of that knowledge here tonight. So thank you very much. That would be all. Thank you. And now, if you have any questions, I would be excited. I don't know if we have anyone on the stream, but I guess not. But if you're shy, you can also ask on this. Yes, sure. Mm-hmm. Okay, great question. Should I repeat? Okay, thank you. Thanks. The question was how to propagate like some tracing ID so you can track performance or correlate requests across multiple services, right? Without including it in the message in the protobufs. So thank you for that question. The question is not so much related to protocat, but to gRPC. And basically, there is metadata in gRPC. There are several types of metadata, but basically you should think about it as like HTTP headers. So you can pass in some key value string or binary data. So you would use this probably, so you don't need to include it in every message. So basically, you can add metadata, key value storage to each of the requests, and you would then take it from the metadata and pass it around the same way you would do for REST calls. You would probably have this in headers as well, right? So did I answer your question? Okay, I'm going to trust you on this one. So is there any question? Other? Something else? I see nobody typing, so and nobody's on the stream, so I assume there's nothing on the Slido. Okay. I guess there's nothing else. In that case, thank you very much. If you have any other questions that pop into your mind, feel free to get me up after the show. And now I suggest we have like 5 minutes break before the next talk, so you can use toilets, beer, whatever you need. And this would be all. Thank you very much. Pum, 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 pum.
Bych tady nebrebentil, tak mě možná se vypní. Pum. Jo.
A podle je ten spot.
A kdyby se mě někdo chtěl něco zeptat na tom streamu, takhle? Takhle.
A budete vidět tady.
Tak jo.
Ale já se obávám, že tam nikdo není, takže můžu být úplně v klidu,
Můžu
nemusím být nervózní.
je úplně upřímnej.
Jo.
Tak to jsem rád.
Tak. Ještě jsem chtěl něco. No.
Nerozbíj mi to, ale až mi to funguje teďka.
Takhle jenom jsi viděl, jak to vypadá, jo? Takže když stojíš tady, tak je to v pohodě, když uděláš krok někam jinam, tak vylezeš tady z toho okýnka.
Tamhle ta kamerka, ne? Nebo? A to asi docela funět, člověče. Jo. Jo. So, thanks for the technical help. I believe we are going to start, so if anyone is interested about this wonderful title of gRPC Operations Nightmare, you can like join me on my talk or grab a beer or something. Do you mind maybe to tell them or something? Okay. Okay. I'm just generally not sure if they are not interested and just chatting about something else, or if they are going to join us. But okay. Tough crowd. It's all right. No rush. Grab your beers. It's like we have a whole evening, so. Yeah, thank you all for coming. Thank you all for sitting down and everything. So I'm going to talk about gRPC Operations Nightmare for gRPC, obviously. It's a cool feature. I know I'm Linux user, so this is like totally modern age presentation, which is actually working pretty much correctly. It's nice. So as I said, my name is Martin. I'm DevOps engineer. It's like a cool thing sysadmins are called nowadays. Actually, there's like a certification from Google which says that I am professional cloud DevOps engineer. So I usually say that because DevOps is real for some reason, even though it's a culture. So I'm a DevOps team lead in here. I do not really know what that actually means in real, but whatever. I like beer. I do like to work with Python. Which is kind of odd. Yes, I did not really understand the talk Yara was talking about, but that's all right. He'll later tell me like he do every day, so that's like how we roll. So yeah, it's one of my internet jokes. Only I can laugh at. So this is the part where you are going to find out if you should grab another beer or just listen. The other people cause it like a summary of stuff. So we'll talk about the motivation behind gRPC. We'll talk about traffic management, which is kind of tough. We'll talk about runtime, which is basically containers. And we'll talk about monitoring. So what's the motivation behind gRPC? Yeah, I'm so happy that there is so many backend developers in the audience. So it usually goes like this, we have a great protocol to use, please prepare infra for it, thanks. I'm just too poor to buy pictures, so this is how the world portrays you, the backend developers, image of excited programmer man showing thumbs up while working with the computer in the office. So that's like the excitement phase, then comes the negotiation phase, it's already running. I love that one, it's like you can't say no to that, it's already running. We kind of felt uncomfortable to tell you. I do understand that as well, especially if, I have a talk about it later on. And customer agreed too, yeah. And Google use it as well. This one is actually really important for me. That means that somebody is going to support it later. That's like the motivation part. But let's get serious. I'm just, they are going to beat me later, so that's all right. So what's important from operations point of perspective? So basically, we usually care only about these three SLA, SLO, SLI, where it's like the basic. SLI is just a service level indicator. Those could be like an availability, error rate, latencies, and so on. Basically everything which you can monitor. Then we have objectives. They usually say like what should be the threshold in some given period of time. So let's say the availability on the month should be like 99.99%, which is kind of average thing to ask. And then there is an agreement. So that usually says like, okay, so if the objective is not going to be reached or it's going to be above the objective, what's going to happen afterwards? Are we going to pay for it? Are we not going to release for a while? It kind of depends. So that's like the main thing we are considering all the time where it's something new. So we do not really that much care about the protocol itself, especially if there are some indicators we have to follow. So what are those objectives? I already talked about them a bit. I think that for most of the application, those come up to these three I have here, like the availability, which is usually 99.99. And this is not something which is given. That's something we usually guarantee. But it's usually decided based on the discussion with the customer. So for us, it's usually like 4 minutes and 22 seconds of downtime. This is something protocol have nothing to do with, but it's really something you have to follow up with. Then you have latency, as Jara already mentioned. gRPC, for the most cases, uses HTTP2. So from the point of perspective of the transport, the latency is slightly smaller than for HTTP, I don't know, 1.2 or something. Same goes to throughput. Everything is in binary, so you are not transferring that much data from one endpoint to the other. So that's usually much better. And what are the tools we actually use for follow-up these objectives, indicators, and stuff? So that's why we have traffic management, load balancer setup, TLS, and stuff. That's why we have container runtimes and monitoring to keep everything alive and running. So let's discuss traffic and how we roll in gRPC. So everything is an HTTP post. There is nothing else. Everything in gRPC is transferred via HTTP post. That kind of means that there is no convenient CDN setup you can use. You just have to provide something else or something more, let's say, robust, like, I don't know, you're up in different regions and stuff. There are no GET, no HEAD, no HTTP method actually relates to the real traffic which is happening in the application. Options are sometimes called, but they are not called for gRPC. They are usually called if you have API on different domain than your front end. So they are there just to negotiate some course headers. It's just not really designed in this way. So it kind of depends, but the general recommendation would be that it would be nice to keep all of your static data cached somewhere else, and just keep gRPC requests for the request you would use post in the REST in the first place. And since we are like repeating about everything about post, and everything is in binary, there are like some more unrelated issues we are going to have throughout the lifetime of the project. So this is just a curl command which is copied from Chrome networking tab, where you can just open network and find the requests which are like happening throughout the communication with the backend. And you can just copy the curl and paste it into the terminal and see what's going to happen. So obviously it usually gives you this warning that the output is in binary. So you have to explicitly say that you are okay with the code being displayed, because it can just break your terminal. This makes every debugging kind of difficult. You always have to keep your protofiles and stuff updated. For some basic calls, you have to use tools like Bloom RPC and so on. Which is kind of inconvenient if you are like having some alerts in the middle of the night, let's say, I don't know, 3 a.m. And you want to just find what's the root cause of the issue. Yeah, so that's one of the problems. So how we actually handle traffic management in the projects with gRPC and Ackee? Well, we usually have Cloudflare, not in the role of CDN. I'm going to talk about it in a bit. We have GCP load balancers, community service. Usually there is some Envoy because of the gRPC web filter. That's the only way you are able to display data from gRPC backends into your browsers. And there is some poor little container with the backend up running. Well, about that Cloudflare and the support, it's supported-ish. You have your slide button there, and once it's on the right, it's running, it's supported, it do the stuff. Once it's on the left, it's not, it's disabled. And, you know, ish. This is a cool photo bank picture, so I don't know, I just love them. So as I was saying, you are having your web application firewall, that's actually enabled by Cloudflare. You are having bot management, which is kind of odd. I'm not really sure if Google is able to, let's say, ask some gRPC endpoints about some search engine data. You have page rules, which is kind of important. That's really nice. That's really convenient. There is no Argo tunneling, no Cloudflare access, which is kind of reasonable. And of course, since everything is HTTP post, there is no CDN you can use. Then we have GCP load balancers. They have some minor setup issues with health checks. I have a few slides about it. I'm going to whine a lot in this talk, but it's all right. You already came and you have your beer, so you have to suffer for a bit. It's kind of supported. The gRPC is kind of supported. It's really simple. You just have to enable HTTP to support. That's basically it. And then we have Envoy. And we use it just because of the gRPC web. Its configuration is written in YAML, and it's usually really, really long. I have an example. You know, I was kind of thinking that I have a lot of slides, but then I remembered that all of them, well, 5 of them are about the gRPC configuration. So now we are going to talk about all the points we have here, and I'm going to detailedly explain all of them. Not really, because I do not really remember what they are doing. There are, I don't know. Yeah, I have few points in here because I was so sure that I'm going to forget. Yeah, so there is gRPC web filter setup. There was like 4 lines. I think the configuration is like 200 lines. There's self-signed TLS setup. That's because HTTP2 won't work without TLS setup. There's admin endpoint, which is kind of convenient for Envoy because you can at least see what's happening in case something's broken. And there's CORS header setup, which is something new for us. Well, new. We were used to backend developers setting up CORS headers and their Express and so on. But now it's totally managed by Envoy, so there's usually some problems with backend developers asking if we can fix some CORS header issues. So that's kind of tough. And now let's just discuss a few words. Well, let's have a few words about runtime. And it's kind of conveniently connected because Envoy is just a proxy which is usually used in Istio, which is service mesh. And for that we usually use Anthos. That's just a GCP implementation of service mesh. Istio actually manages Envoys for you, so you do not really have to know how the configuration works. It's just everything is done for you. If you are using Anthos by GCP, it has SLA, so in case something is broken, you can at least write on support and ask them if they can fix it. And if not, you can just claim some credits back, which is always nice. Somebody else is going to suffer because of some mistakes. I love it. It's kind of easy to use, yet it's expensive. Again, it's once you are paying for something, it would be really nice if it would be really easy to use. The model how you are paying for the stuff is quite different. Usually for GKE, you are paying upfront some cash for control plane, and then for some nodes which are running in your Kubernetes cluster. And here you are paying just for CPU cores. It's a bit hard to pronounce, so if I'm going to mix it with Anthos, it's the same thing. Sorry. Yeah. as I said, it's kind of expensive. It's like, as my colleague wrote, ASM CLI is a tool for bootstrapping Anthos clusters, and this is like the thing they have once you just push the enter button on terminal and try to deploy the cluster. So usually you have to have at least 4 CPUs per node in the cluster, and at least 8 in the whole cluster. So if you are having some small project and you are like thinking, okay, so I want to use service mesh, everybody's talking about it, I just want to try it, you know. Maybe not with Anthos, depends on your budget and how small is your small project, but I wouldn't really suggest it. But you know, when you remember that Envoy configuration I showed you before, this is the service definition in Kubernetes. And it's doing exactly the same thing as the Envoy config I showed you before is doing. The way how you can say that the service is running gRPC web is just by saying that the name of the port is gRPC web and then something else. You know, it's just the important part is the name of the port, and that's basically it. That's a huge difference, right? It's like a one line, and for Envoy it's just a, I don't know, lot of lines. But you know, at the end it's still service mesh. You know, it's really complex, kind of hard to use, even though it's supported by Google. It's really hard to debug, especially if something is happening. And I do understand that, you know, arguments which sometimes pop up on Twitter when you talk about the service mesh, that nobody really needs a service mesh. Yeah, in a way, if your load balancers are good enough and they are managing the traffic and the protocols you are using, you generally do not really have any use case for service mesh. But in case of gRPC, it's something different because you are having like MTLS already set up, so your HTTP2 is working by default. You can just, you know, set up your gRPC web just by saying the name of the port, and it's really done. You know, the only thing, you know, once you get really excited is that you have to have your use case for it. If you are planning to deploy just one service running some gRPC web thingy, I don't know. I wouldn't like to be in a skin of people, you know, asking their project managers about, you know, I want to use service mesh for this, and you know, how much would it cost? I don't know. It's not really worth mentioning. You know. I don't think that this would fly. Of course, there is some lightweight solutions you can use. On GCP, there is Cloud Run, which is really nifty tool. You can just deploy your container as an Cloud Run service. There are no hard configuration options if you maybe know Knative. I think Google stole that and just used that for Cloud Run. It's running really smoothly. It's really lightweight. They say that the gRPC is supported, but whenever you are trying to use gRPC web, you again have to install some Envoy as a second service. They have the same thing for ESP protocol, which is like something for distributed control planes and so on. Doesn't really matter. So at the end, you are just having like 2 containers, one with Envoy, which is like forwarding the traffic to the container with running application, and the one with the application. So you are kind of paying for the traffic twice. You know, it have to always be forwarded from Envoy to the backend and back through the Envoy back to the web page. It's kind of hard to debug. It's not really, you know, fun to play with. We have a wonderful blog post from Pepa Gattermeier on our blog. So if you are interested to try it, you are more than welcome. I never made it to work. So of course there's no SLA. So once this is getting broken, you can't really ask about anything on support. So now let's have a few words about monitoring. It's going to be depressive as well. So I've said that for the load balancers, there's like some mighty small issue about the health checks. And this is like the UI representation of health check in GCP. And in here you can see that I can't really edit that health check. You know, this is just a health check for gRPC. They support it. It's all right for them. Google is using a lot of gRPC services for the SDKs. Whenever you are trying to use gcloud command, is usually using some kind of gRPC endpoint. So I think they are like utilizing gRPC for almost everything. Yet if you want to try it, you have a really hard time just to deploy a health check for gRPC. So if I can't edit it, can I at least create one, since this is like already there? Well, not really. It's not really even in the options for protocol. You have HTTP, HTTPS, 2, SSL, TCP. There is no gRPC, but GCP API actually allows you to create the health check if you know how. So we can just send a request through API. It's going to happen. This is the representation in Terraform. So it's totally able to create that health check for you. You just have to call the API for that. I have a feeling that not even Google is taking their protocol seriously. They are using it, but I don't think they are like willing to let other users to use it as well. I don't know. They are just maybe making this a bit harder. I don't know. One more thing, I was saying that load balancers, they are like able to transfer traffic in HTTP2 and everything is working. But once you start to dig in the logs, especially if you are having some kind of issue and you are quite used to debug some REST endpoints, this is not going to be really helpful at all. Everything is paused, so method is going to be still the same. Request URL, yes, you can at least see the endpoint. You also see a status, which is like 200 in here. But I think Yara already said that for gRPC there is a totally different status codes. So this actually doesn't really mean a thing. So how to kind of work with it, how to solve it? Well, you kind of have to log everything by yourself. So these are the container logs from our applications, like from our backends, and they have every info you can like dream of, especially because usually there are some kind of issues and we are not able to find out what was the root cause. So we always ask the backend guys, okay, so could you please add something there or something? So I guess it was really growing by the time. So in here you can see the methods, the metadata, which are the headers from HTTP call, if I'm not mistaken. And of course there is status, which is 0, and that's the status of gRPC call, not the HTTP call. Kind of funny, right? I don't know. I find it funny. Of course, streams, which got introduced by Yara, they are really nice. It's a totally new concept. They are really fun to play with, especially if you do remember how tricky the WebSockets were. So I guess there is, of course, some kind of bummer. Usually Cloudflare hangs up every connection after 100 seconds of inactivity. So be prepared for your clients to know how to reconnect to your endpoints. Other than that, it's like totally unusable. Of course, recycle your opened connections from the browser because I think Chrome Chrome has like a limitation of 6 connection to one hostname, and it's not really that different for other browsers. So if you are like trying to open a multiple connections from one browser to one backend, it's going to fail. Of course, streams are like usually continuous. They are not stopping for anything. So of course, if you are trying to measure latencies, it's one of the indicators customers are usually interested in. You will have to find out something else, because this is like the example from our Grafana, and you can clearly see that the TTL from our connection is usually like up to 30 seconds, because nothing survives 30 seconds. But if you are like measuring in general like your latency, and you let's say say to your customer, well, every connection the front end is going to make is going to last at maximum of 200 milliseconds, you can't really monitor it in the way you were used to for plain REST requests. You have to come up with something else. So usually you have to create some new dashboard and get the status from the backend application and from their logs. It's generally a good idea to know if your backend developers are going to introduce streams into the production, because it kind of happened to us that it was like introduced and there was like an alert, and we were not really aware that the alert is related to the streams. So yeah, just one of the hints. Yeah, I already mentioned error codes. This is a good one. Here you can see how the response from terminal is going to look like if you are okay with displaying binary content in your bash. So in here we can see that the response from HTTP was 200. Everything was flying, everything was all right. But oh no, gRPC status was 13, which is, I think, internal error. And as you can read, atom SS memory outside buffer bounds. So if you are like planning to, let's say, monitor the return codes for HTTP, it's not again going to work at all. You have to again explore, export the status of the gRPC code, and have some custom monitoring for that. Yeah. So is it really that bad? I know that I haven't mentioned that many nice things about gRPC, but it wouldn't be that funny. I don't know, I laughed, so it's okay for me. So is it really that bad? The world has to rest. It's just a statement. Don't beat me up for that. Visionaries are usually paying the highest price. If you are planning to disrupt the whole world of REST APIs and just use HTTP as your transport protocol, it's all right. Just be prepared. It's not going to be that easy. If you are like changing anything, it's going to be expensive, and usually small steps are more easily adopted. I have one example from the networking world. So everybody has NAT in their home, in their routers, even in this office, but not that many people are using IPv6. And if they do, they're usually talking about it quite a lot, so you would know them. So the same goes for like gRPC. We talk about gRPC quite a lot. So it's not really that easy, And let's give it a year or two. That's the same thing you can do with IPv6. It's going to happen. It's going to be much more well supported. It's going to be fine. But gRPC is here since like 2015. So the only thing I'm happy about is that Google is still supporting it and working with that. So it's going to get better one day. But at the end, how we are actually rolling. So I said we are still, using it in one of the projects. So we settled with Istio on Anthos because of the SLA and the support from Google. So it's going to get better, And for the increased complexity, we use Argo CD as a CD tool for, to see the stuff which is actually happening, to see the deployments. We also use rollouts in Argo, which are really helpful if you are planning to use some advanced strategies for deployment, like, canaries, blue-green and stuff. And that's the way we kind of figured that's the most usable in our case. So generally, it's not really bad at all. Your use case might not be good enough. So if you are planning to have like a small app and just have gRPC just because it's fun and it's new and Google use it and customer also agreed, just maybe think about it one more time. It's not that simple to deploy and keep running throughout the years. It's not even that cheap if you are planning to use Anthos. But it's totally able to run for, let's say, thousands and thousands of customers which are, watching news or something. So when is this actually useful? As I said, for requests which couldn't be really cached, that's really important. There is nice integration with almost every language, especially, whenever you tried, in Python Word. So if you tried using like Firebase and Firestore and stuff, you just import a library, it's going to happen, but the SDK is actually using gRPC as well. That's why the compilation time of the library of the package in Python takes such a long time, because it's compiling some C++ stuff. And there are like definitely the improvements because of the HTTP protocol, which is kind of fine. Again, you have to use TLS with HTTP2, which is sometimes not really that simple to do, especially if you are like trying to debug something on your local machine. Okay, and that's basically it from my side. I totally enjoyed the talk. Hopefully you did too. So if you have any questions, just don't hesitate to ask. If not, like there's the beer. That's where I'm going to go to, like in a minute. Yeah. No one. Thank you very much. Well, sorry, stuff. I think the use case is the main blocker. Yeah. As I understood it, the question was somewhat like the operation is the main blocker, why not using it on more than 2 projects. I think the use case is the main blocker because the stack have to, well, it's just so much simpler to use something like GraphQL, for example, if you have some small app, because of the way how it's handled in the HTTP world. You are not forced to use binary protocol on everything. I know that I said it's convenient in multiple ways, but if you have like a use case like Google has, I don't know, like some backend which does not really provide that much of static content, which needs to be managed by post requests, and there is like a lot of data which could be streamed, and it's not really that simple to transfer a lot of plain text data, and you would really appreciate some binary because it's much more smaller, then I think the use case is much better. I'm not entirely sure if it's the best option if I would be creating, let's say, like a web page, and I would like to use gRPC as a backend because of the gRPC web and how it's handled currently. But again, it's like getting better every day. I was like checking the Google because I have there that the only way how you can work with gRPC web is just deploying Envoy in some way or the other, because Istio is also some way of deploying Envoy. Currently, you can for Golang deploy some middleware which will do the same thing. It will just expose one port for gRPC web and one for gRPC, and it's really simple to do. And Google has a lot of endpoints written in Golang, so for them it's totally convenient. So again, my answer would be if you have a correct use case, which is not really easy to find, it might be a good choice for you. Other than that, I would probably consider GraphQL, which is like good as well. Yeah, thanks for the questions. Like, at least somebody asked something. Okay, so you can clap now, and it's down from me. Thank you very much.
It was my 1, 2, 3. All right. So we are approaching the end of today's meetup, and I will be the last piece of the puzzle, because you heard backend, you heard DevOps, and I will tell you something about our experience from the front-end perspective. I'm Lukáš Horák, and I'm front-end tech lead here. And my presentation today will be about if gRPC requests can be faster, because they are fast. For imagination, let's assume we have an application. It's a React web-based application, React-based web application, that fetches and mutates data over gRPC. It uses gRPC web, but not the original one, but the fork from Improbable. Improbable is some company. I honestly don't know what they do, but they use gRPC a lot, so they made their own fork. The reason they made it because they need some important features that are not part of the original gRPC web. For example, the server-side rendering support, or not the server-side rendering support, but support of gRPC at server-side rendering part. And our application also supports Czech region. So there are users that come to the application from Czech, but it needs to extend localizations to other regions. So there are plans to add another regions and to support another users from other countries. So this is simplified scheme of how our application looks like. You can see there's some happy user from Czech that comes to the application and fetches data from backend. As Martin mentioned, there's some envoy, proxy, doesn't matter now. And we are adding another region, so we add a Slovakian region and another happy user. There are also happy users from United Kingdom, hopefully. And also, we need to add a Brazilian region. You can see the user is happy, but he shouldn't be. Because if we look at the list of requests we made from that example application, these are from Czech region, and the requests are pretty fast. They took approximately around 55 milliseconds, and which is not so bad. But for our Brazilian user, they took approximately much more, around 400 milliseconds, which is 8 times more than from our Czech user, and that's something we need to solve, and we need to deal with, because we don't want to our Brazilian users to be angry and to be upset because they have slower application than we in Europe, of course. So, what we are gonna do with that? You may come up first with some idea of adding a data center that will be located in South America and replicate data and load balance the user that comes to the application. So they will be from Brazil. They will be much faster because they don't need to go for data to Europe. But as I was told by my colleagues from backend, it's not so easy and possible in gRPC, because data replication it's not so easy in gRPC, and also, which I was told by my colleagues from DevOps, thank you, Martin, it's really expensive. So this wasn't a case we can go with, and we have to find another solution. So we came up with an idea to reduce amount of requests, because if you look at the list of the requests, there is a lot of requests that are not some data requests. These are the posts with data, but there's a lot of options requests, and these are, yeah, we'll get to it what these are. But if we would be able to reduce them, there's like half of request remaining, and which means a much lower and shorter loading time. So that was the way we decided to go with and to implement. So now there's a question: how to get rid of options requests? To answer that, we first need to tell what options request is and why it happens. Options requests are here for because of course policy and for some security reasons. There's some definition from MDN network, and it says that the options requests are made by browser to check if the request to another domain, another server, because cross of course means cross origin, cross domain requests are here for sake of safety. Halo, ještě pořád se jede? Tak to zkusíme.
Tam dáme ty nový.
Okay.
To si stejně natvakní.
Yeah.
Tam jsou křičáky.
Are we there? Yeah. So we can continue. Where did I stop? Yeah, cross-origin request. Because of request cross-origin, cross-domain, and they're made by browser to check if the request is secure and if it's reachable. Because if it's not the same domain, we don't know. So what we need to do to get rid of options request is to avoid course policy being applied. But how can we make that? How can we avoid course policy being applied? As everything, not everything, but almost everything in a web application development, if you're stuck and you need to find a solution for a really hard problem, the simple answer is to use iframe. And for that case, we use iframe hack. Yeah, it's not the official term, it's our term, we call it that way. What is it exactly? Iframe hack consists of two simple steps. First step is to insert an iframe to our web application, and in the iframe load some dummy plain HTML that comes from our API. And the second step is to proxy all requests from our application through that iframe, because when they're going through the iframe, they basically come from the same domain to do backend, and that means they're not cross-origin, they are same origin requests, so there are no options requests. So the architecture looks like that. That is a design of the solution for our problem, and it looks simpler, right? What can be wrong at that? You are in gRPC world, and nothing goes easy when you deal with it. So there are problems. First problem or first obstacle we had and we had to solve is how to load the dummy HTML in the iframe, especially how to get it from the API, because as you already heard, gRPC communicates with binary data, and if we need to load a plain HTML, it can be binary. It can be compromised. Never mind. You know what I mean. It must be just the HTML. And again, as I was told by my colleagues from backend, it's not so easy and possible. So we had to figure it out and find an alternative solution. Yeah, that's the problem. And the solution we find was to use something called Cloudflare workers. If you don't know what Cloudflare workers are, it's servers by a reverse proxy Cloudflare. And it's a way how to handle some requests. How to route some logic for handling requests that goes to the reverse proxy and respond earlier before it reached the backend. So the solution here was to write some simple Cloudflare worker that handles the special URL. And on that URL, when the request came here from our web application, then the worker handle it and responds back with the HTML we need. By the way, the HTML looks very similar to the one on the slide, so it's really nothing special. And that was the solution we did, and that works. So we're moving on. Another obstacle or problem we had, how to proxy the request to iframe. We need to use the iframes fetch, because we are using, in that case, we're not using XML request, we're using native API fetch from the browser. Who of you who are developers, web developers, you know fetch. But we can't use the web application Windows fetch. We need to use iframes window fetch. How to do that? That was the problem, because we use the gRPC web library, and the library makes the request somewhere inside it, and we are not able to write it by ourselves. We don't use the fetch from our application. It's somewhere inside, deep inside the gRPC web library. Hopefully, there's a mechanism provided by gRPC web library from Improbable that's called transport layers, which is a mechanism to abstract the underlying browser primitives and to provide a way using the primitives you want. So you're able to use gRPC and wherever you want or need to replace the communication primitives like fetch for WebSockets or for XHR requests. So we use that. And to use it and to be able to do it, we had to write our own custom transport layer. So how could that custom transport layer look like? Yeah, it's something like that. That's not the transport layer. That's how we are using it, because you can see we made some transport layer, and there's some simple utility called setup proxy that basically do the easy job of creating the mentioned iframe, inject it into the page, and then return the element, DOM element, and we're using that iframe element passed to the transport, make a new transport, and inside the transport, the iframe element is used to use the iframes fetch, and we take the transport and set it as a default transport for all gRPC requests, because there's a gRPC from Improbable Inc. and we set the default, and that's all. We used our transport. And now you may ask how really that layer could look like. Yeah, that's what we did. The layer is basically what you, because it's a really long code and I wouldn't be able to show it all, but it's basically the fetch transport that's already part of gRPC web library, because they have some of these layers already included. We took it, copy-pasted it, our favorite part, and then changed just 2 or 3 lines, which made a simple thing. And the thing was that we provided a new context, and context means context in which the fetch is executed, and use that context to execute our fetch request on it. So before it was just fetch from the current window, but we made it possible to provide a custom context, and that custom context could be our iframe or iframe window. So this was the second step, and I told you that our hex consists from 2 steps, so now we're done, right? Yeah, you wish for. No, we're not, because here came another problem. When we did that all, we also thought that we are ready to go to production and test it all, but we now started to getting this weird error, and you can see the error doesn't say much about what's going wrong. Something about response calls without gRPC status header, with some general error you can get from very different reasons. It basically means that some things get wrong. So we had to involve our engineering skills and go deeper into the code, do some debugging, and it was like 2-3 days of debugging. One of the worst parts of it. And then I found out that there is a broken instance equality because we changed the context of when the fetch is executed. Maybe you don't know what I mean by that. I'll explain. If you look at this code is from JavaScript implementation of protocol buffers, and it cares about transferring the byte source to some JavaScript primitive, some uint8 array. So nothing much special, just converting type of data. But the important thing here is the data object that's passed to that function is a data object that we got from our fetch. And our fetch is now from iframe window. So even if the data object is of the type byte source, which can be uint8 array, because its type byte source, but byte source can be uint8 array or several different types. And in that case, it's uint8 array, but it's from the context of iframe window. But, another but, we are executing that code that JavaScript protobuf utility in our web application. And since it's executed in our application, then the uint8 array here is from the context of window. And there's an important statement which might maybe surprise you, but window uint8 array is not the same as iframe window uint8 array. Even if the iframe is a part of the window, then its window has different reference to uint8 array. So that was the problem, and inside that utility, if I go back, then you can see that never of the check in that utility passed, so the conditions fall through, and we got to the last step, which is assert for fail, and it throws some error about not convertible type of data, and that was the error you you saw. So we had to solve that, And how we did it, it was just a slight modification of our custom transport layer, because inside that layer there's also what I showed you before was a utility or function for writing data, and there's also a function for reading data. And inside that function called pump is reading the chunks of data. And what we had to do is a small hack and to provide a window event array as a constructor, because it just need to reference the point to correct reference, and this is the thing that solved the problem and didn't broke anything. At least I hope. So we are approaching the end, and you may now ask what's the result, because after the last step everything worked as we designed it, and now there's a time to evaluate results. So duration median is similar, which means we didn't make requests faster, we didn't speed up the application, but we managed to decrease number of requests by half. You can see there are no options requests anymore. This means a reduction a lot of time of loading data, and that was the result we got. So to answer the questions from the title, I tricked you a bit. This presentation wasn't about how to make the request faster, but how to decrease the amount of them. Yeah, this definitely that solution and that technique can be applied even out of gRPC. But if you try it with gRPC, there will be problems I described, and you should be aware of them. Thank you for your attention. And if you have any questions related to the presentation.
I just would like to ask, I really appreciate and like the hack, the way how you did it, but why not just move the route, do a route on the load balancer to redirect every request that goes to, you know, your domain / API to the AP super container. Stuff like that. It would save you from all the requests that you mentioned. No pre-flight request because it's the same origin, and it would be much simpler. You actually first repeat the
Yeah, I know. I don't remember it again. Yeah.
just about moving, you know, just to hide your API on the same domain and solve the redirection on the load balancer. So it looks like
Yeah, that's the question is about if it would be possible to solve that by by moving API address under our web application domain. And I would like to answer it too, but I guess the best one to answer is CRDAO, because it's a design of backend. Yeah.
Okay, perfect solution for the problem. The problem is that there's no /API. Everything is on the root, and actually gRPC has this odd specification that you cannot move it to a subpath. That's why we need to have it on a subdomain to actually fulfill the gRPC standard. This would be an excellent solution. We would love it, and we inspected it, but it is not possible. You would need to do some other hacks on the backend and the infra. Maybe I'm simplifying it, but I think this is the gist of it. You cannot move it on.
that you can use I'm not able to do it on the infrastructure just to, you know, forward everything.
Then we call to our third speaker.
What a question, right? The thing is that we couldn't make the envoy make it the work we wanted to. Like you kind of would have to strip the prefix from the request to, you know, just remove the API from the beginning of the call, and it was kind of hard to make it work. And after a while, we kind of decided it would be like easier to make the iframe hack.
And like that, I really like it, but I think that you know things that can get go wrong in the future. You know how the library
Repeat.
will change and stuff like that. So. So think about it.
So the remark was that it can get really hard in the future.
Thank you.
Yes.
We'll consider it next time. Definitely.
A wonderful question, though.
Yeah.
And the last question, I would like to ask you. I think that you are able to cache the personalized request on the web for up to 2 hours. Why did you do that?
I don't think so. It's possible with gRPC, but I'm not sure. Yeah, Jarda? Tell me.
You can.
It's weird. Okay.
Sorry for the skipping and forwards. You can do it, and we actually do it. The problem is the cold start. When you open the homepage, you don't have it cached in your browser, and the first time it loads, it's very slow. So this was the problem we were trying to solve. But this, I don't think you enable it. I think it's usually in the browser by default, and you don't need to do some juggling. Good point. For the repeated request, it works, but for the cold start, you still get like a lot of options requests that we don't really need for the security reasons, because like it's not cross-origin, as Lukáš explained.
Any other questions? But sorry. Honestly, I don't know about any web application powered by Google. They mostly use gRPC for backend-to-backend communication. So, yeah.
Is it possible to do some request batching? To merge multiple requests into one?
Yeah, but that's the same like with REST. You can do that if you make some special endpoint when it will be handled some batch, but there were different requests. They weren't on the same service, were on different services. So maybe for the same service, there will be some requests like that. But anyone else? Because if there are no other questions, we had, I don't know if it's a surprise, but great ending of tonight. And it's a quiz. It's not a pub quiz, and it's a quiz for some, for some prizes, merch. I don't know, it's prize money, I heard something about prize money. But we'll see.